From South Bend, Indiana, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
I like to say that the sintering portion, the debind and sintering portion, the furnace portion of the operation is your magnifying glass. So if you've made any mistakes, anything that you've done that's diverged from your general path, the furnace is going to show you that.
That's Bryan Sherman. Bryan is a seasoned metallurgist with over 2 decades of experience in metal injection molding and sinter-based manufacturing. He is chief metallurgist at DSH Technologies, where he focuses on debinding, sintering, and process development across both MIM and metal additive manufacturing. Bryan's background spans part design through full-scale production, giving him a unique perspective on process control, repeatability, and quality. As interest continues to grow in sinter-based additive manufacturing, Bryan brings valuable insight into what the AM community can learn from the decades of maturity and lessons developed in the MIM industry. Before we get started, head over to www.3degreescompany.com and subscribe to the podcast. Remember, you can listen to the show anywhere you download your podcasts, including Spotify, Apple, Amazon, or Stitcher. Also, if you or your company are looking for materials, qualification, data management, or general additive manufacturing support, reach out to the team through our website or via email at info@3degreescompany.com.
All right, Bryan, thank you so much for joining the show today. I'm really excited about kind of the breadth of what we can talk about. A lot of times we focus on some of the early stages of additive with materials development and kind of the builds and all that stuff. But a lot of I think, discussion today will be around what you and DSH does. DSH, it's early here. So just got in from shoveling. It was like we had another 4 to 6 inches last night. But anyways, I'm warming up. So, I think the conversation will really kind of hinge on some of the other parts of the process and of making an AM part that are often overlooked. So I'm excited for that. But like we start with every guest, we like to get to know you a little bit better, and would love to know more about kind of where you were born, where you grew up. Okay. Do you remember some of those formative days that kind of pushed you towards manufacturing, engineering,
Sure.
and kind of where you got your start?
Well, thanks for having me, Mike. I appreciate it, and this is a great opportunity for me. So, I grew up in a small town called Eldred, Pennsylvania, which is about 45 minutes north of St. Mary's. And St. Mary's is well known for being a hotbed for powdered metallurgy industry. So I've been around it all my life, and it was interesting growing up in a tiny little town, and then progressing to Penn State, where things got much bigger, much faster, and my life changed quite a bit in that regard. So, pretty cool.
So for people who may not be familiar with, we've got listeners that kind of span the breadth of what they do in additive or non-additive. Mm-hmm. But when you say powder metallurgy, what does that mean, or what is your vision of that?
Okay, so tying it back to St. Mary's, that's traditional PM, which would be press and sinter type of things. But the powdered metal industry overall encompasses not only press and sinter as the basis, but also metal injection molding and now additive manufacturing in powdered metallurgy. And it's a huge field, and it's very diverse. There's anything from automotive to medical to firearm, you name it, is being made out of all 3 of those major technologies.
And so did you have family? Did you know a lot of people working in the powder metallurgy space when you were growing up?
I did not. I just happened into an opportunity at Penn State through my material science program to work in Dr. Bryan Sherman's lab for a couple of semesters, and that really introduced me to powdered metallurgy and introduced me to metal injection molding, and then ultimately additive later. So
what was your first job out of school?
My first job out of school was with Allied Signal before the merge with Honeywell, and it was actually to develop a novel new binder system for metal injection molding.
Awesome. So when did you start hearing about additive, or when did that come into your purview?
So that was pretty interesting because very early on in my career, in the very early 2000s, 2001, 2002 timeframe, we actually did a project with Boeing out of Southern California that was using a nylon binder basically to additively make uh, turbine parts. So I've been around the additive side since almost the very beginning. It's pretty cool.
Awesome. And was that with DSH as well?
Yes, that's when that's at the point where Klaus Jurgens and I got together and decided that it would be great to have a company based on educating our customers on how to do their processes better and to also help improve the equipment as we go along. So we started DSH in 1999.
Okay. What was that? What was that like? Kind of early days starting a business.
Oh, quite a jump for me because it was not that far out of college and had worked for a huge company in Outlet Signal, and then just start something up and it's just a couple of people. It was a great experience early on in my career.
Do you remember what were the demand signals for that? Like, were you seeing kind of a lot of challenges in that space? Like, what was it that kind of really pushed you over the edge? Like, oh, hey, like there's not just one or two people. Like, there's a lot of people that have this issue.
So from Klaus's side, he was seeing how his customers were not utilizing the equipment very well.
Okay.
And from my side, it's me having to teach people what we do, how we do it and why we do it from the furnace standpoint. And also from, the very beginning of the process, selecting powder, selecting binder, working your way through the progression of making the part. But I like to say that the sintering portion, the debind and sintering portion, the furnace portion of the operation is your magnifying glass. So if you've made any mistakes, anything that you've done that's diverged from your general path, the furnace is going to show you that.
Mm-hmm. And so is this? We talked a little bit about the part of metallurgy, and it encompasses additive, metal injection molding, kind of the binding and sintering process. But like, where do you guys often start conversations with customers? Or like, is it metal injection molding? Is it additive? Like, where, like, even throughout kind of as you started to now, like what?
Yeah.
When do people come to you like, oh crap, I can't make this, or like my last 100 parts suck, and like is that like where it is, or more like up early stage, like, hey, we want this alloy combination, we're getting a ton of shrinkage when we do the furnace binding sintering process, like can you help us like talk more about that?
Sure. So existing customers typically come to us when they've got a problem that they're having a very difficult time solving. Either they're trying to move into a new alloy and they don't understand it, or they're having some sort of binder interaction with this new alloy, or they're having a fundamental problem with the part. The part cracks every time they run it, something like that. And those are things that we're happy to tackle. We're happy to take on and help people work through. But basically since 2018, 17, 18, when additive really started to grow fast, we had a huge influx of customers that were like, we don't have any idea what we're doing. Please teach us what we need to know so that we can go out and make parts. So that's where pretty much where you start from the basics. You start from, okay, this is the fundamental powders that you should be using. These are the sizes. This is probably the best system for you as far as printing goes. And then we'll step you through all the furnace processes and we'll get you to the end part.
Where was a lot of your early, focus in that time kind of the binder jet, or were you working on kind of some of the laser-based processes too?
So we don't do a whole lot with the laser-based processes because the only furnace step they need afterwards is typically annealing.
Yeah.
So the binder jet you requires debind and sinter. So that's where we really shine, and that's where we really step in and help the customer learn what they need to know so that they can execute that properly.
What are the high-level things that they need to know? I imagine kind of powder shape, morphology, particle size distribution, all the thermal properties, but maybe like what's in 30 seconds, what's the, like, if you know this, like that's a good starting point.
all those things come into play, but if you're talking binder jet or similar type technology, at the end of the day, you really need to match what you're trying to make, the part or part family you're trying to make with the right system. Because if all these systems can probably produce the part, but
by system you mean like what machine, what brand? Is it an X1? Is it just whatever else?
The machine, the binder system that machine comes with, the best utilizes. Like I said, you can make the same part in all these different systems. Some of these systems will shine, and some of these systems will not make the part very well. And it's really a part by part basis or a part family basis that you have to look at, and help steer the customer into what's going to best serve them to make the part successfully every time.
Interesting. So is it, when you say kind of what system, is this more of is it more of a material science type of issue where it's like, hey, binder alloy combination versus like my maybe naive understanding of it was like, okay, hey, like you look at an HP, you look at a Swan, fundamentally it's laying down a layer of powder. If you get like the flow right, you can do that. And then it's layer by layer. It's not that complicated, not that different between the systems, right? But what they're putting on it, the alloy combination, that seems to be where the magic is. But is it more than that?
Yeah. So some of the binder systems just flat out will not work with certain metals. Sure. And knowing that is super, super important, obviously, but also the interaction with the binder and the powder is different in different systems. And that's where some systems shine with certain types of powder morphology and certain types of part geometry, and others fail.
So even if you have the same binder system, same powder, two different machines will look different, or it could be different.
Well, here's some of the stuff that people don't, when they're selling their technology, they don't talk about that much. HP's binder system is totally different than the 5 or 6 different binder systems that Desktop has offered. Is different than the X1 binder system that's offered. I mean, so they're all unique in certain ways, and it's matching up the unique properties you get with the part that the customer ultimately wants to make to get the best part repeatably.
Got it. And where do you see kind of those winning use cases? Is it like when I see it, some of the trade show? Honestly, like I've not done a ton with binder jetting. A lot of our work has been in the polymer powder, metal powder, in the laser-based systems, and so like we come across binder jetting, but not in the wild so much, like with some folks. But where do you see some of the end use applications being like, hey, like good application for this compared to other powder metallurgy or other AM processes?
So I'll speak to one of our customers who I have a ton of respect for. We have a customer out in Michigan. They're called Azoth, AZOTH. And those guys came to us completely naive, not knowing a thing about what they're going to get involved with, just knowing that they could take a binder jet technology and they could make parts and they could make money. Then they asked us, help us, realize this. So we taught them from the absolute beginning, the basics of, what they need to look at, what they need to understand. And they ran with it. They really ran with it. And, they're one of the most fantastic success stories. I mean, they've won part of the year at the MPIF show, and they're only, since like 2019. So that's a really young company to be doing parts that win part of the year. So they're a great success story, and they have found fabulous success with automotive, a lot of automotive low production run stuff, some medical, and one of the most unique things that they made, and it never got the fanfare it should have. They worked with a chainsaw chain manufacturer making one-off chain design, chain tooth shapes, and it was far easier for this company to test something that they just binder jetted, this unique new altered geometry for this chainsaw link, and it was fabulous for the end company. I don't remember who it was, but they were able to do iterations in a week rather than months, and it really changed their perspective on how they could bring new chain tooth designs to the market.
Awesome. And what in the binder jetting process, what are some of or are there differences in terms of end use mechanical properties that you would typically think of in some of the powder? Like there might be directionality, there might be shrinkage. Yes. What are those things that you kind of keep in mind when you're designing a part or thinking about, hey, here's my existing part or existing kind of target, like what should you be thinking about?
So one of the things very important to understand is the fundamental difference between your XY and your Z shrinkage. Your XY is fairly consistent. Your Z is less so. If you're using FDM, it's dramatically different. If you're using binder jet, it's less so, but it's still there. So that's something you need to take into consideration. The build, the way you orient the part to build is very important in any of these binder jet or FDM type applications, because your Z is always your weakest, and it will the part will literally pull itself apart if you can't orient it so that the Z that you've printed is the Z that goes in the furnace.
Got it. Okay. And are there what are the, like, as you think about kind of taking a step back to more the powder metallurgy conversation, you've got additive, binder jet in that conversation now. Like, what's the delineation where you would think, okay, hey, metal injection molding makes sense for this, or or an additive or another process? Like, do you in your mind, like as you're talking to customers, like what are some of your decision points that like, okay, hey, maybe this is a good fit, maybe it's not?
So typically, if you're going to use if you're going to move more than 5,000 to 10,000 units per year, it's worth having a conversation about MIM.
Okay. Is that because of the tooling, like amortizing like tooling costs, like that starts to make sense?
You have to amortize the tooling cost. That's a big justification because tooling can be very, very expensive. When I was producing MIM parts, I worked for the largest captive MIM organization on the East Coast was for a firearms manufacturer, and I worked there for 6 years. We had tooling there that was well in excess of $100,000. So you really need to justify what you're going to get back spending that kind of money on tooling.
Yep, for sure. And so where do you see kind of the emergence of additive companies that are familiar with metal injection molding that are starting to bring it in and say like, hey, we need to at least diversify a little bit? Or is it new companies like an Azoth? I don't know much about Azoth, but I don't know what their background was, but maybe they had it, maybe they didn't. But like, where do you see kind of the adoption of more the AM side coming into the market?
So Azoth is a great example. They were tooling. They were the parent company was a tooling company,
like CNC too, like making CNC tools.
CNC tooling, the building tools, you name it. But the guys that actually run the AM side of the operation, the Azoth guys themselves, they were basically shortly out of college. They were young, they were hungry, and that was good for them. Now, looking back at my career, I would have jumped at the opportunity had the technology been there for me to take my feedstocks and produce parts quickly and easily. A good example is it is not binder jet. It's actually utilizing MIM feedstock. There's a couple of producers in Europe, and there's a producer in Ohio that are building machines that will take regular metal injection molding feedstock pellets, and it'll act like an FDM machine, except you don't have the spool. You have a hopper containing the pellets, and you can literally build layer by layer prototype parts. And I would have loved that. That would have saved me so much work, so much time, so much effort if we had that technology available back when I was working at the firearms manufacturer.
Yeah. And where, as you think about the industry as a whole, like where are some of the big gaps that still remain?
So we saw early on a lot of the metal injection molding companies looking at all the various AM technologies to do that, to fill that gap, to do exactly what I would do with it, which would be, let's do my prototyping. Let's see how the part performs. Let's see what the geometry problems are going to be through the AM stuff, the binder jetting or the FDM, and then we'll go and we'll learn, and then we can build our hard tooling and spend the big money.
Got it. That makes sense.
Yeah. So it fills that gap. It's really good. It's really effective at filling that kind of gap.
Yeah. And do you see, I mean, you've mentioned a little bit about like specific industries, I mean, firearms and some of the medical stuff, but like who do you see as kind of the early adopters that have been looking at it, but more like is there a more maturation, like, hey, like this is a good industry for this, or this is good application or use case?
Yeah, so turning it that right back to the prototyping medical devices, it's fantastic for that kind of thing.
What sort of medical devices, like just like
You
or
can
alloy, or like what alloys are they using, like to
Well, so they can prototype up new um, joint replacement parts and things like that, or new tooling to help install the existing joint replacement parts.
make sense? Okay.
Yeah, it's very very good at that.
Yeah.
And that can be stainless steel, it can be titanium, uh, cobalt chrome.
Yeah. And so going back to you a little bit, kind of what's a day in the life look like typically?
I spend a lot of my time working directly with customers, going over their questions, working with them over a longer term to help them solve their problems. Many of our customers, particularly in firearms, uh, they struggle with carbon control in their low alloy steels, and so we spend a lot of time working through all the science behind what's going on to get the carbon into the right range, get the oxygen into the right range, and then make the process as robust as it can be, so they make the same part every day.
And with that, I mean, I'm curious. One of the things that we've talked to some other guests recently about is like um, additive over the last 10 years has kind of gone through these ups and downs, and
Yes.
new technology comes and goes.
Mm-hmm.
But also it there's one of these things where there are a lot of shows that are specific to additive, and
Yes.
kind of there's a little bubble, but I imagine a lot of industries have that. Probably there's the metal injection molding show, there's a firearm show and things like that. But how do you, does do the customers you're working with who are doing some of the binder jetting, do they fit more in kind of the powder metallurgy space, or are they more in the additives? Like how are they kind of finding their niche of customers and talking to the right people, and like where are these people meeting together? Where are they kind of making connections and
So the successful ones I honestly, it's hard to define exactly why they're so successful, but they're certainly getting to the right target audiences. Whether that's through shows, I don't think so. I think that they work to create connections in their comfortable space. We have a customer in Raleigh who does basically it's micro binder jetting.
Okay.
They make parts that are like the head of a needle, and they make a ton of them, and they make this all for the medical, and they're wildly successful with that. But they've been able to really cultivate relationships with many medical companies, so they're not captive to one. And I think being successful if you can find that niche that you're good at, and then bring in multiple different customers that are in that arena, so they're not captive to any one customer.
Awesome. Cool. Just a handful of more questions
Sure.
as we kind of wind down. But what excites you looking kind of over the next 6 months to a year? Are there things on your radar that are new technology, new applications that are really exciting?
Sure. So, first thing is I'd like to see more of a rebound in the binder jetting. I think that it's going to come. I don't think it's going to be anywhere near the great fanfare and craziness it was a couple of years ago, but the rebound there, I'm excited about. I love working on new projects. I love working on new alloys. Those challenges are very fun to me. That makes my job very interesting. And I love meeting new customers. Meeting and cultivating relationships with new customers.
And so with that, I mean, we haven't really described your company in a great detail, but like,
Mm-hmm.
how do people find you? How do people kind of like, what are some of the capabilities that you guys have or
Sure.
like to work with and engage customers?
Sure. So we have solvent debinding capability here. We have catalytic debinding capability here. We have multiple furnaces that are Elmic furnaces. They're all metal design. So they're capable of nitrogen, hydrogen, argon, and vacuum or mixed gases. And we provide toll services, where you can just send as much product as you want and we'll process it for you. Or you can come to us with fundamental questions. How do I process this alloy? Or what do I need to learn so that this alloy system is going to work in our equipment? Then we'll teach them, we'll educate them. A lot of my job is education. It's really getting the customer to understand the fundamental science behind what's going on as you progress through the steps of making these parts. So we provide those services. We work with some labs to do all the lab work that may be required. We do a lot of carbon and oxygen testing. We do some dilatometry work. We also do some TGA work through some supporting labs.
Fantastic. And more of a fun question as we wind down. Every year we do a 3Degrees Discussions book list of guests' favorite books or reads that they've had over the last that has made an impact on their career or something that they do in their life. So any additions from you that you'd like to share?
Yeah. So a few years into my career, I read Getting to Yes.
Okay.
And that was a very good
follow-up, Avoiding No. Did you get the...
Yeah.
That was a great one.
It is. Yeah. That was something that was influential.
Fantastic. Well, Bryan, I really appreciate you joining the show, telling us about what you're doing. We will share all the links and point everything in your direction when we get the chance and when this goes up. So really appreciate it. Thank you.
Sounds great. Thank you very much, Mike. I appreciate the opportunity.